Well, hello, Natural Resources class. I'm recording this just after our last lecture on Monday, so I still will have no news on my wife's surgery. I will try to give you an email after Wednesday. But anyway, I want to pick it up where we left off on Monday and today. And in the notes that you can see on the left, hopefully you can see on the left side of the screen. My cursor will work. Where is my cursor? We left off right about here with lumber prices. In the old days, post-Civil War, early 1900s, we would see $12 to $18 per MBF. That means 1,000 board feet. I got stuff piled all around me here, so if I'm fumbling for stuff, please forgive me. But about $12 to $18 per 1,000 of these. If you remember these from lecture, this is one board foot. Okay. So back post-Civil War, they would get $12 to $18 for the equivalent of 1,000 of these. Nowadays, you can see if we move up in time, the year 2000, the average price for lumber was $350 per 1,000 board feet. Again, MBF stands for not million board feet, but 1,000 board feet. And then, and this is sort of a summary, an average of all the different variable, the variety of different types of lumber, some more expensive, some less, that kind of thing. In 2008, it dropped to $260 per 1,000 board feet, and that we've talked about was the last time we had major recession, more, just a crash in the stock market, all the declines in our economy, and then, as noted in class in 2021, during the height of the COVID deal, we had an average price of $850 per 1,000 board feet. And that was the point of this particular diagram that I showed you, how the prices spiked. And we said that was because of two things, primarily. Increase in demand as people were at home wanting to do construction projects and had the money to do it. And then B, that there were not the mill workers to keep the production up where it needed to be. So with an increase in demand, a drop in supply, we saw an increase in prices. And that's kind of where we left off the other day, on Monday, today actually. So big producers, Canada is a major producer, U.S. is a major producer, Sweden and Finland in Scandinavia, Germany still is. Interestingly enough, New Zealand is a major producer. And then Brazil. And then I have Russia in parentheses. It's still a major producer, as I noted in that moving diagram, if you will, that I played for you on Monday. But the reason it's in parentheses is because it occupies a rather interesting spot in our world today. I've already made the case that Russia has more forest land, huge area of forest land. If we zoom out and we look at, well, let's just put Russia in here. You can see that, well, we'll go there. You can see the area of forest land in Russia is just phenomenal. It's huge, more forest land than any other, Prussia Township, than any other nation on earth. So we'll just go there manually. Just kind of scoot over to Russia here. Anna's home country. We'll get back north. There we go. And just look at the vast expanse. Much of that is forest land. Some of it is arid steppe grassland, but a lot of this area is forest land. And it is also in close proximity to one of the biggest markets in the world, and that's right here. That's China. This is Mongolia. So, major market, major forest provider, major forest products producer. But I wish we were in class, Anna, to ask you this particularly, but the line is generally from economics classes that I've got in geopolitical studies of geopolitics, is that Russia and China don't always get along the best, for lack of a better way of saying it. There can be tensions between those two countries. There have been when it comes to fossil fuels, crude oil, just not wanting to get along the best and exploit those obvious, unique situations of geography with close relationship. But yeah, just a big situation there that doesn't seem to want to get resolved. Just a very kind of an interesting situation. So anyway, that's why Russia's in parentheses. Big potential there. In fact, a lot of the big producers other places in the world kind of tremble at the thought of Russia and China getting things ironed out, because that would really put a kink in the markets, if you will, if a lot of China's supply would be filled by Russia. Anyway, we also went on and we talked about this already. And this is a 2005. That's an older stat, but it's still consistent. 63% of all U.S. timber was harvested in the South. And the Pacific Northwest was the big player. They saw a major decline in in timber harvest because of that critter right there. This is on an environmental science textbook. That's a spotted owl. And a few years back, it was decided that it was in sharp decline. And it's a major habitat. We're national forests and along the Pacific Northwest from California up through Washington. And so major portions of the national forest were closed to timber harvest so as to keep the habitat of the spotted owl. And so that helped drive things to the south as well. Now there's still major areas of timber harvest going on in the Pacific Northwest. If we go to Oregon, and anybody from Oregon will cringe at my pronunciation. They always want to say Oregon. You can go to Oregon and on Google Earth, and you can look in this Pacific Northwest part of it, and particularly up north here, and you can see logging is still a major player. All these pockmarks here are logging jobs, but I'm going to quickly point out that this is areas that have been harvested, but they are replanted, regrown. That's a major industry here, is basically tree farming, growing trees. And I'll show you a video clip another day of what that looks like. So anyway, I guess let's do a little math here. 15. Okay, so really, when it comes to energy, though, not much of the world's energy needs come from wood. You probably all know people that cut and split firewood and burn it in their house. I do. But it's not a major. We do it just for kicks and grins. And maybe that's the case for you. And it's not that many people that would actually depend on wood solely for energy in the United States. You go to developing nations generally, and the number ticks up dramatically. 25% of developing nations really look to wood as their primary energy source. And we go to Africa in particular, 50% of the energy needs of Africa come from wood. And so that's a major thing to think about regionally. It's important in certain parts of the world. There are generally two types of forests, and you've probably heard a lot of information about them. I'm going to read you a couple of items here. This one comes from a textbook I use in another class. It says, presently there's great concern among scientists and laypersons about the destruction of the world's rainforest due to logging and the large numbers of persons who are starting to live and farm there. Well, how much is that destruction? Well, here in this textbook, it reads, according to the UNFAO and the World Resource Institute, satellite sensing shows that the world's tropical rainforests are vanishing at the rate of basically 42 million acres per year. Wow, that's a lot. This source here is another environmental science textbook. It says every year humans are destroying an area of forest equivalent to the size of Oklahoma, which we made the case was about a little more than 44 million acres. So 42 million to 44 million. And finally, the WWF, not the World Wrestling Federation, the World Wildlife Fund for Nature, World Life Fund, depending on the year you're talking about. It says, they say, and this is a preservationist group, in the time it takes you to read the sentence, another 8 acres of rainforest will have been bulldozed and burned off the face of the earth. That's 63 million acres. So from 42 million to 63 million acres are vanishing. Well, some of that's hyperbole, and if you look at the actual numbers, according to Lomborg, and he did a lot of crunching of the FAO, Food and Agriculture Organization, tropical rainforests currently constitute about 2.2 billion acres, or 23% of the world's forests. they're losing about 0.5% a year, or about 10 million acres a year, which is still too much, but it's not 66 million acres a year. And so, yeah, in some places, there's a lot of regrowth of forest, and so some places that's harder to do. I'm going to explain why here in a second. Now, when it comes to characteristics of that rainforest, we can look in these pictures that I've shown you before at that lush growth. And if we were in class, I would ask you what you thought of the soil fertility underneath an area like you see in this picture. And I'm guessing you would think it's a fairly fertile soil because of all the lush growth there. In reality, it's not. It's a fairly non-fertile soil. And so let's look at that in a little more detail. So half of the rainforest, roughly half, is in Brazil, Indonesia, and the Democratic Republic of Congo, the DRC. So if we go back out, you all know where Brazil is, of course, in South America. I had a student last semester from the DRC, from the Democratic Republic of Congo. So this is Brazil. Okay. Indonesia, okay, is here. Okay, this is Indonesia. And then the DRC, the Democratic Republic of Congo, right here. Okay, formerly called Zaire. And you can see lots of rainforest there. There are other places that have rainforest, Southeast Asia, these other countries in Africa, so on and so forth. But you know, a lot of it, those countries really have you know, the bulk of it, 50% of it. So lots of rain, hundreds of inches a year. Just for contrast, Minnesota gets about 30 inches a year. This year, I think we're going to go probably north of that. But now, of course, warm temps if it's a tropical rainforest, very diverse forests, but poor soil. And let me show you some examples of that tropical soil. Right here, this is in Madagascar, but this is what a tropical soil looks like. It's very thick. But if you think about it, there's lots of heat. It's a warm environment, lots of rain, and that means you got lots of a chemical soup, if you will, and water washing that through that soil profile and right out of the soil profile, washing any nutrients through the soil profile and right out. So that if we look at this picture right here, these plants are grasping any nutrients that might become available rather suddenly in that very uppermost soil layer right here before the rain just washes them into the soil profile, right through the soil profile and out of the soil profile, and creating this sort of a look. In that kind of a condition, only the most insoluble or hard to dissolve types of elements remain in the soil. And the two major elements that are hard to dissolve are aluminum and iron. And if I had to ask you to guess what you're looking at here, I'm hoping you would say iron because of the color, and you would be right. Now, clay also sticks around, pun intended. That's the size of the soil particles here. And so if you remove the vegetation and try to farm it, that's not going to work very good because it's a very infertile soil. So pretty quickly you give up on the farming. Now you've got that soil denuded, stripped away, doesn't even grow grass very good. It bakes in that sun and it cracks and looks like this picture that we see here. So those tropical soils are not good places to do agriculture. They're just not. And people are figuring that out. It just doesn't work too good. So that's summarized here. Nutrients are quickly utilized by the canopy or washed away, and aluminum, iron are the things that are. There's so much iron in some of these tropical soils that they can actually be mined for their iron, and the iron extracted and made into steel. That's a lot of iron. That's a concentration of iron. Well, temperate soils, temperate forests, these are a bit different. Well, in temperate situation, that word temperate means we have 4 seasons. We've got about 7.4 billion acres, or about 77% of the world's forests. But look at this. We're gaining about 3.6 million acres a year. And that I'm guessing you will probably find surprising. And really what's going on is, if we look back at this, I want to pull up another type of another Word document. A picture to have in your mind, it's very common around this part of the country, is this picture right here. And if I can get it to, I might just leave it that size. Here you have an old agricultural field that has been abandoned, and it's reverting to forest. Here's another one. It used to be grazed or corn growing on it or something of that sort. And here's another. And this one I just took recently. Very familiar with this. I even remember when hay was baled on this field. And now these are white pine trees, deciduous tree of some sort growing here, cherry maybe. Lots of bigger white pines in the background. Given up on this. And if you think about it, hopefully this makes some sense when we consider the characteristics of this kind of soil. Let me go back to the document, the description here. So we're seeing a gain. Where's it coming from? Well, what's going on? Well, there's less rain, so 20 to 40 inches like we would see around here. This is less diverse types of forests. It's still got its own diversity if you think about, sorry, I inadvertently hit the pause button here. But this is, you know, what a northern hardwood forest would look like. And it looks like we've got an oak tree here, and we've got an ash tree here, maybe a maple here. So there's, you know, tens of species possibly totally there. But nothing like a rainforest situation where you have, you know, hundreds of species present in this particular picture. So yeah, so why? So here's the key: moderate to poor soil. So if we look at soils in our part of the country, see if I can get that picture up here. Where did I put it? Right here. This is very typical. Just well, mostly north of the cities. Around here, it's mostly a pile of sand or clay. But you go just north of the cities, and this is what our soils look like up there. Lots of rock and not that much soil over bedrock. And this stuff is not real fertile, folks. It's more fertile than a rainforest soil, but it's not very fertile. And you know what? You try growing corn in that, and you're going to grow a field of rocks a lot better than you're going to grow a field of corn. It'll work for a while, but pretty quickly you'll get outcompeted in the price of seed and chemicals for growing corn in this day and age. You're going to really quickly get outcompeted by bigger farms in southern Minnesota and Iowa and places like that grow a lot more corn per acre than you can grow north of the cities in northern Minnesota, northern Wisconsin, northern Michigan. And it's kind of sad to say, because those are oftentimes family farms that have been functioning for generations. But now we're finding that they're not able to compete, and so those farms might fail, and that's kind of sad. But it's understandable. And when they do, well, those fields, they shoot. I want that picture if I can get it. Oh, I got to move me. Sorry, guys. This field, you know, even the hay crop, it didn't justify paying the property taxes on it, so the activity didn't. So the people just sort of let it go back, and it's no longer producing agriculturally. And you know, that's a hard thing, maybe, but maybe it's a good thing. Maybe it's our economic situation working like it's supposed to. And switching, like we saw in Georgia, switching from growing cotton to growing trees, because it works better there. So here's some stats. These are from the U.S. Statistical Abstract, and you can see the increase in temperate forest land. This is just in the U.S. In the years mentioned here, and it is in fact increasing through time. And the average is 3.6 million acres. And that's a pretty good chunk of forest land growing back. Now that temperate forest land, it's interesting if we go back to the economic issues that we were talking about earlier. We truly have a world market, a global market. I went into a Home Depot a few years back, and I bought a 1x4. This is a 1x4. This is a piece off it. It was 8 feet long, but this is it's supposed to be 4 inches by 1 inch. Well, it's actually 3.5 by 3/4, but I'll talk about why that is maybe next video, why we've been able to reduce the size of it. We would call this still a 1x4. But if you look at this, I don't know if you can see it. I'll try to hold it to the camera where you can see it. If you look at the label right up there, it says made in Sweden. Ladies and gentlemen, this is not an expensive piece of lumber. We make lots of these at sawmills in Minnesota, but Home Depot decided it was cheaper, they could make more money off a board they imported from Sweden than to buy it from a mill here in Minnesota. And the backside, this is a label off another one. This one came, same board, 1x4, not this one, but another board like it, came from New Zealand. What in the world? The deal is, you know, it might be something like New Zealand or Sweden paid for the shipping to get it over here to bolster their lumber production in their country. Some way they were able to outcompete a sawmill in Minnesota, given the incredible shipping costs there must have been, and ship this board, one from Sweden, one from New Zealand, all the way to Minnesota, so I could buy it in a Home Depot store when we make them here just you know, a few tens to hundreds of 100 miles away from here. Incredible. On the same note, I had a client give me these two labels off of firewood packs. She bought firewood. This is just across the border in western Wisconsin. The only deal is this one right here, this came from Latvia. If you look up here, if you can see that, it says Latvia. And this one right here came from Estonia. There's even less value in firewood than there is in 1x4s, but still we're able to import them. Somebody's able to import them and sell them when you can go less than 10 miles and cut firewood. It's incredible what goes on with that. So anyway, I'm going to stop talking there, and we're going to pick it up here in a couple minutes with silviculture. Thank you.